Dear student, myself Dr. Surekha Jaiswal, Head Department of Physics, Moreshwar College, Bhokardan. Today we will see topic viscosity and surface tension. Course code number Phy101, semester first. Now, today's topics are viscosity, types of flow, energy of liquid or fluid. Now, viscosity. It is defined as the resistance offered to a layer of fluid when it moves over another layer of fluid, or it is the property of a fluid by virtue of which it offers a resistance to relative motion between its different layers is called viscosity. Now, see in figure, we have a fixed surface, see in figure, over which a fluid is flowing, and the thickness of fluid layer is denoted by Y, see in figure, and the layer which are in contact with fixed surface having zero velocity, that is denoted by U equal to 0 in figure. Here see that layer is in contact with the fixed surface, so having here the fluid having velocity, that is U equal to 0, and as we go on moving away from fixed surface, the velocity goes maximum, that is here denoted by U maximum. See, that is fluid is flowing at that point, here at that point, at that surface, the U is maximum. It is observed that when different liquids are flow through plane inclined surface, each liquid is flowing with different velocity. This difference is due to density of liquid, and it is natural properties of liquid. This property of fluid is observed in gases also. Viscosity is mechanical property of liquid and gases related with flow. It is defined as volume of liquid that flows per unit time through any section, or it is also defined as mass of liquid flowing through unit volume per unit time. Now, examples are: when water in a beaker is stirred with a rod at its center, the layer of water in contact with the rod moves with the rod. The layers near the walls of the beaker remain steady or stationary. The intermediate layer will move with intermediate speed. When stirring is stopped, the relative motion between its layers gradually decreases, and finally the water comes to rest or after some time. The difference in speed between its different layers is due to the property of viscosity of the liquid. Now, another example, that is a similar phenomenon is observed when a vessel containing a liquid is rotated. The outer layer in contact with the vessel move with its, while the inner layer move with lower speed. Now, similarly, the viscosity of sea water makes the water waves subside. Due to viscosity of air, raindrop falls with less uniform velocity. Now, fluids have complex motion. The nature of the motion is determined by the velocity, density, and the pressure at any point in the fluid. It is not an easy thing to explain this complex motion. So instead of explaining the complex motion of the actual fluid, an ideal fluid is assumed and its motion is studied. Even though the motion of real fluid differs from an ideal fluid, it is assumed to reflect the motion of a real fluid in general. Now, an ideal fluid is incomplete. This shows that the density does not depend upon the position in the flow. The density remains constant at any place in the flow. The motion of an ideal fluid is rotational. This shows that the flow does not depend on angular momentum of a particle in the fluid. So the equations governing the motion are simple. An ideal fluid is non-viscous. If the fluid is non-viscous, then there is no loss of energy in overcoming the viscous drag. All its point energy is utilized for the flow only. And the flow of an ideal fluid is said to be steady or streamlined in nature. Now there are two types of streamlined flow and turbulent flow. Now streamlined flow, that is, if the velocity at any point is constant in magnitude as well as in direction, the flow is called as steady or streamline. Or the velocity at a point in a fluid is independent of time is called steady or streamline flow. If all the particles in the fluid move an exactly same path, that flow is said to be streamline flow, and the path followed by the particle is said to be streamline. See in figure here, that is a streamline flow as shown in figure. A streamline is a curve such that at any instant the tangent to it at an point gives the direction of the flow of the liquid at that point. When a liquid flows through a pipe and as much it leaves the pipe as enter its per second, the liquid is said to flow at a steady rate. Now see in figure, the rate of flow of liquid may be expressed in terms of its volume that flows out across the is known as cross section area in unit time, or it may be also expressed in terms of mass passing out per unit area per unit time. Now in figure, if a liquid is flowing with a uniform velocity v, see the liquid having the, as shown in figure, the layers of liquid having the uniform velocity v perpendicular to the section x and y, each of area a, small a, and travel at a distance small l in time t, then its volume flowing out per second is given by L into A upon T equal to V into A. Or different in streamline flow, the kinetic energy needed to drive the liquid is used of only in overcoming the viscous drag unit between the layers. This type of flow generally observed at a lower velocity and in narrow tube. Now, when the streamline is curved, the pressure is greater on the convex side than on the concave one. The flow of remain streamline so long as the velocity of the liquid does not exceed a limiting value known as the critical velocity, beyond which the flow becomes turbulent. Now, what is critical velocity? When the velocity of any line of flow exceeds a certain value, the flow changes from laminar to turbulent state. This minimum velocity at which the flow changes streamline to turbulent state, it is called critical velocity of that liquid. It varies from liquid to liquid and has higher values for highly viscous liquid. Now, turbulent flow. As the velocity of the fluid increases, the particle state start to move in zigzag path, and the velocity at which the zigzag motion of the particles start is termed as critical velocity. The eddy current and the sideways movement occur after the critical velocity, and this type of flow is called the turbulent flow. The external energy given for flow is wasted in forming eddy, and if the velocity at a point in the liquid flow changes with time, forming eddies and velocity, the flow is called turbulent. In general, liquid of high viscosity having streamline flow and liquid of low velocity and high velocity, high density have turbulent flow. Means in general, the viscosity is high, then flow of liquid is, that is a streamline flow, and when the viscosity of liquid is low, then the turbulent flow. Now, energy of liquid or fluid. A fluid has inertia, therefore it possesses three types of energy. Kinetic energy. If any fluid of mass m is flowing with velocity v, then kinetic energy equal to half mv square. So, kinetic energy per unit volume equal to 1 half mv square upon volume. So, kinetic energy per unit volume equal to half rho v square, because mass upon volume, that is a rho. Now, potential energy. The potential energy of fluid of mass m at a height h above the surface of earth will be potential energy equal to mgh. But potential energy per unit volume will be potential energy upon volume equal to mgh upon volume, that is rho gh, because m upon v, that is the rho. So, potential energy per unit volume is given by rho gh. Now, pressure energy. The force on the piston equal to pressure into area. Now, force equal to P into A. See here, that is the P is here pressure on that piston. See, that is a tube, and here that tube having the area, that is a capital A. So, force equal to pressure into area. So, work performed to push the liquid inside the tube equal to W equal to force into displacement. So, force having the value, that is the pressure into area, and displacement is here place, that is denoted by here small d. So, P into A into D, that is a work done, and W equal to P into delta V, and this work is called pressure energy. Pressure energy here W upon delta V equal to P. Now, total energy of liquid equal to E equal to kinetic energy plus potential energy plus pressure energy. So, E equal to half mv square plus mgh plus P into delta V. So, total energy per unit volume equal to E upon delta V. So, E upon delta V equal to P plus half rho V square plus rho GH. Thank you.